Okay, hi everybody. I just wanted to go over this quick card with you that you will get today or sometime soon. This card explains what happens with certain types of rotations. So, what I want you to write on this card though is somewhere at the top or in some sort of space, I want you to write that these are only for about the origin. That means that these rotations or these rules for rotations are only when your shape is revolving around the origin. It's not when it's revolving or rotating about a vertex. But I'll go over that later, but I wanted to make sure that you have this on your card. For these tricks, you'll notice from hopefully from the Desmos activity that you just did, is that a rotation of 90 degrees clockwise, you will start off with an original ordered pair, which you saw in the activity. This column here is for any ordered pair that you have. It doesn't matter what it is. This just represents your original ordered pair. And when you saw in the activity that when you rotate it 90 degrees clockwise, something always happens with your coordinates. They switch places, so your x becomes the second part of the coordinate, and your y becomes the first part of your coordinate. And then the x value that now is second becomes opposite. Now I know on this card that it says negative, but it's negative of whatever that is. So for example, if your ordered pair was a 2, 4, it's going to flip-flop into 4, 2, and this one becomes negative. So it'd be 4, negative 2. However, if these were negative numbers, like -2, -4, this would be first become -4 and -2, but this becomes opposite. And since originally it was negative, it now becomes positive. Okay, so this negative sign doesn't mean it's always negative. It's the negative of whatever x is. Okay, now you can see in this table also, this row right here is about rotation of 90 degrees counterclockwise, which you start with the original. Your coordinates flip-flop spaces again, but this time the first part of the coordinate becomes opposite of whatever it was, the negative of whatever it was. So in both these, no matter what, if it's a 90-degree rotation about the origin, for sure you know your coordinates are going to flip-flop places. You then have to figure out which one will become opposite. Will it be the second one or the first one? Okay, and I'll go over that in a second on how you could figure that out. Now right here, rotation of 180 degrees, it doesn't matter which way you go, you'll end up in the same spot. Again, you'll start with your original coordinate, but these don't flip-flop. They only become opposite signs of what they were, okay? Now you'll notice in the rotation of 270, they're very similar to rotation of 90. And if you can see, this one right here, 270 clockwise, is exactly the same thing as 90 degrees counterclockwise. And 270 counterclockwise is exactly the same thing as 90 degrees clockwise. So really, the only ones you really have to know is these top three here. Okay, so I'm going to show you just off to the side here real quick. If you had a coordinate grid, and let's say you had a dot, a point right here on your coordinate grid, you can see this one is in the first quadrant. I'll label the quadrants here. Okay, if I'm going to say that I want that dot rotated 90 degrees clockwise, I know it's going to land here. So I know, let's pretend that this ordered pair, I'm just going to make it up. Let's pretend it's 3, 2. If I land here or go 90 degrees clockwise, according to my rules, I know these two are going to switch places. So I know it's going to be a 2, 3. Now to figure out if which one becomes opposite, you can use your quadrants to help you. If you know something's going to land in quadrant 4, you know that those ordered pairs have to be positive, negative. So this number 2 has to remain positive, and this one turns negative. So you don't actually have to memorize which one turns. opposite if you can realize what quadrant they're supposed to land in. So for example, if I'm going to go 90 degrees counterclockwise, I know again, since it's a 90-degree rotation, I know for sure that they're going to switch places. Well, now I'm in quadrant 2. So I know it's got to go negative positive no matter what. So I know this 2 is the one that's got to be negative. So as long as you remember that your 90-degree rotations flip places, then that your coordinates flip places, then you can figure out which one turns negative. Or that's how I do it, okay? Again, the rotation of 180 degrees, clockwise or counterclockwise, if it starts here, 180 degrees is always going to be in the quadrant diagonal from it. Well, you can tell already that if I put my dot here, I know it's going to be negative, negative, which is exactly what happens. Now, the one thing to remember is on rotations of 180, they don't switch places. So it just becomes -3, -2. Okay. Now, the last part, just to go over real quick, rotation of 270, that means if I start here and go 270 degrees clockwise, I'm going to go 90, 180, 270. It's going to land here. Well, that means that if I go rotation clockwise to here, that's exactly the same thing as starting here and going 90 degrees counterclockwise. I would land in the same spot. That's why this one and this one are the same. This one and this one are the same. If I go 270 degrees counterclockwise, that means I'm going to go this direction. 90, 80, 270. I'm going to land right here. Well, that's the same thing as starting here and going 90 degrees clockwise. That's why these two are the same. So that's why you really only have to remember these. Now again, this is only for about the origin, when something is rotating around the origin. Okay, I hope that helps you understand the card and understand some of those tricks.